Hello, web developers. This is Kevin, and I'm the product manager of Azure Web PubSub and Azure SignalR.
Hello, friends. This is Ken, and I'm the engineering manager of Azure Web PubSub and Azure SignalR.
So, Ken, what are we talking about to the web developer community today?
Well, today we are going to talk about implementing real-time features on the web. More specifically, we are going to talk about an open source library called Socket.io.
Oh, that's great, since the Socket.io is very popular with JavaScript developers. But Ken, you live and breathe real-time technologies. Can you help us understand what you mean by real-time?
Yeah, for web development, when we are talking about real-time, we are referring to the situation where the server sends messages as soon as something interesting to clients takes place.
Can you give us some concrete examples?
Yeah, sure. An example I'd like to use here is the auction website. When a visitor comes to a web page and explores the product listings, we want to show the latest prices. As you can imagine, the prices change very unpredictably. From technical perspective, we need a way for the server to push data to clients.
The web largely works on a request and response model. The request comes from the client first before the response. If you are talking about a server pushing data proactively without the clients asking for it, I guess that's why we are talking about Socket.io library today.
Yeah, exactly. Over the years, there have been other solutions based on HTTP, like some pooling techniques, but now WebSocket API is well supported among major browsers. It is a better solution for real-time needs, but using plain WebSocket API can be challenging for large-scale applications. That's why developers have turned to libraries like Socket.io.
I know today we're going to build a real-time notification feature with Socket.io. But before we get into the hands-on demo, on a very high level, can you share with us why JavaScript developers favor Socket.io?
Yeah, sure. Yeah, we ran a developer survey last year and learned that developers love how intuitive the APIs are, which we are going to explore very soon, and how feature-rich the library is.
I'm just scrolling through Socket.io's website. It says it supports reconnection, acknowledgement, broadcast, and among others.
Yeah, broadcast is a feature that is often needed when building real-time web apps. It allows you to send messages to a group of users with just a one API call.
I guess following your auction website example earlier, I can put users who are interested in a particular group and a particular product in a group. And whenever the price of that product changes, I only need to make one API call to send a message to everyone in that group.
Yeah, exactly. This is not something that is provided by plain WebSocket API, but is often needed for real-time app scenarios.
You are getting me really excited about a notification feature we are building today. So developers, if you're interested in learning more about the features and benefits about Socket.io, you can head over to its website. On it, you can also read about the results of the developer survey Ken just mentioned. But without further ado, Ken, shall we start building the demo?
Yeah, of course. Yeah, understanding business requirements is often a good place to start. Kevin, can you walk us through what we're building today?
Yeah, not a problem. Contoso Real Estate is an open source project that demonstrates how JavaScript developers can leverage Azure to build enterprise-grade applications. This is what the real estate listing site looks like. As you can see, you can browse through the apartment listings and make bookings. Now imagine during the holiday season when lots of people plan to travel and apartment listings are snatched up quickly. It would be very frustrating to a holiday goer when they proceed to checkout, only to realize that the listing they're interested in is no longer available. A better user experience would be to send them notifications about the availability of listings in real time as they take the time to decide.
Yeah, sure. Let's put the requirements on the screen and discuss them in detail.
Yeah, so there are two situations where we'd like to send notifications. First, when a user favorites a listing, we'd like to send a notification to everyone who's currently online, something like a user has a favorited listing. And second, when a user makes a booking but didn't complete the payment, we'd like to send a notification to everyone online as well.
Yeah, for this demo, this is great as people who are watching this video can easily see how the notifications are pushed from server.
Yeah, of course, in a real app, we need to carefully think about when to deliver notifications to whom and how to ensure a better user experience.
Yeah, now let's look at this slide and let me reiterate the user flow to develop a better understanding of what we are planning to achieve. Now let's say this user favorites a listing. A message will be sent to the server, and then the server will send the notification to every online user. The message payload probably only needs to be the listing.
Yeah, precisely. Thank you for taking the verbal description of requirements to something closer to implementation.
Kevin, let me just show you the results I've just get working. I have two browser windows open. Each one represents a site visitor. It's the same app we just saw earlier. You see the difference here is that there is a bookmark icon. Let's say this user is interested in this listing and she favorites it. Now look, the other user sees a notification immediately, knows that this user is not requesting anything from the server, but she still receives a message from the server. It is possible because of the persistent connection Socket.io maintained for us. Now, let's do it again.
Oh, that's really cool. Now I can see how Socket.io can complement the typical fetch APIs. So can we talk about how we are going to implement these features?
If you remember from earlier that we mentioned that the web is based on a request and response model. The request comes from a client first. Without a request, the server cannot respond. To deliver the notifications proactively from server to clients, we need something like this. And Socket.io takes a step further. It allows the client and the server to communicate freely, which means any party on either side can send messages to the other. This kind of communication pattern is often described as bidirectional.
That's really cool. That means I can continue using GET and POST requests for some interactions and use Socket.io to handle the real-time needs.
Besides providing the real-time capabilities, Socket.io's API fits nicely in the event paradigm web developers are familiar with. Let me show you. On the right side is the client-side code. We first import the library and create a Socket.io client object. The object is the entry point to all the capabilities the library offers. Just like how we can register an event handler with a DOM element in the browser, we can do the same thing with the Socket.io client object.
I guess here with this line, it achieves what this line achieves is that when there's an event called server message coming from the connection, this callback will be executed in the browser.
Exactly. When the callback is executed, the data sent from the server will be passed in as arguments. Here we don't do anything interesting. We simply log the payload to the console. That's the receiving a message from the server. Remember that Socket.io is bidirectional, and let me show you how to send a message from the client. Different from HTTP request is low latency. The message here is called emit and accessed through the object we just created. The first argument is the name of the event. You can name it whatever fits your app, and the rest is the data you want to send to the server.
How would you use these client-side APIs for the notification feature?
To receive a notification when some other users favorites a listing, maybe we can name the event notify favorite and access the listing from the arguments passed in. When a client favorites a listing, we will emit an event, maybe call it send favorite, and provide a listing title as the payload.
Gotcha. What about the server? What's the server-side code?
It's not that different. After importing the server-side library, we create a Socket.io server object, and this server listens for a connection event. This is one of the built-in events of Socket.io. Whenever a connection is established with a connection with a client, a callback will be executed with the socket object that identifies a particular client.
I guess here what this line does is that whenever a client connects with this Socket.io server, the server will send an event, and the payload is this.
What this does is that when a client emits an event, this callback will be executed on the server.
Yes, the client side and server side code is quite similar, if not the same.
That's why developers like Socket.io. Once you have become familiar with one side of the APIs, the other side is pretty much the same.
So Ken, again, how would you apply the server side APIs to our notification feature?
Since we only have limited time today, and we'd like to keep the demo simple to highlight the core features of the Socket.io. Whenever a client establishes a connection with the server, we listen for the send favorite event from the client. When the event comes, we simply send a message to every online user by emitting a notify favorite with the listing. Yeah, remember, this is the event name we just listen on the client side. We are going to break it down into 3 steps. First, we establish a connection between server and client. Then we send a favorite event when client favorites a listing. And finally, server will broadcast the favorite event to all clients, and the client will render it in UI.
That sounds like a plan to me.
Yeah, as shown on the Socket.io website, first we need to install the library. Yeah, once it's installed, we create a new Socket.io server with a few lines of code. Here we listen to a connection event, which will be triggered whenever a client connects to the server. Here we don't do anything interesting. Let's simply log the socket ID to the console.
So that's the server side finished?
Yeah, that's it. Since for the step 1, we only want to test out the connection, we will leave the actual implementation in step 2.
Let's move on to the client side then.
Yeah, same as before, we need to install the client library first. Here I create a real-time service. We initialize a Socket.io client object in this constructor and inject the real-time service for the other parts of the app to use. Let's run the app and see if the connection is made.
I see the server logs out the ID of the client.
If you open the debug console in the browser, indeed we see a WebSocket connection is made. Okay, next, when a user performs a favorite action, we need to let the server know. Let's locate the real-time service we just created earlier and add a method called broadcast favorite notification. This method wraps around the Socket.io emit API and emits a send favorite event, and the payload is the title of the listing. On the server side, we need to listen to the send favorite event and log it out. And Kevin, where do you think we should put the code?
Since we need to register event listeners, we need to do it as soon as possible. I guess we should do the registration when the connection is made between the server and the client.
Yeah, let's put it here. Shall we run it?
Let's do it.
As you can see, server first logs out the socket ID like before, and it logs out the send favorite event with the listing title. Now that we have confirmed that the bidirectional connection is established, one thing I want to highlight here is that the connection is persistent. Either party can send data through the connection at any time, and no need to take turns.
Now that the server can receive an event when a user favors a listing, it's time for the server to broadcast this action to everyone online.
Sure. On the server side, we just need to call the same emit function to broadcast the notify favorite event to all connected clients. On client side, we listen to this notify favorite event and use this notify function to show this information in a snack bar component. Now that the UI is done, let's test it out.
I'm going to volunteer to test out the app. If I click the bookmark icon on the left screen, which represents a site visitor, I should see the notification on the right screen, which represents another site visitor. Works as expected. Nice job, Ken.
What we have is one Socket.io server handling all clients. In production apps, it is rare that one Socket.io server is enough. Often developers need to scale it out to multiple Socket.io servers. Setting up infrastructure of multiple Socket.io servers and allowing broadcasting messages to work properly can be challenging and time-consuming.
When we ran the developer survey last year, this challenge of using Socket.io library was ranked the highest. And this is an area where we thought Azure could bring value to developers. With the input from Socket.io's developers, we introduced native support for Socket.io on Azure.
How does this native support mean for Socket.io developers?
Well, it means developers continue using Socket.io APIs they know and love, and which you demonstrated earlier, and let Azure handle scaling out.
Okay. Let me show you how it works in action.
Ken, we only have a few minutes left. Do you really think there's enough time for this?
That's plenty of time. We just need to make a few code changes. First, we need to create an Azure Web PubSub resource, which I've done already ahead of time. On the client side, the clients will be connected to a cloud service on Azure. We just need to change the endpoint the clients connect to. And on the server side, we just need to install the Azure Service SDK and make a few lines of code change to configure the Azure Service. And that's it. These are all the changes we need to make. And now let's run the app and see it in action. Yeah, well, nothing interesting on the UI has happened. The interesting change took place behind the scenes. Let's look at the network panel, and you can see the connection is now made with the Azure service instead of a local Socket.io server.
I see. Since the client is connected to an Azure service, it relieves the pressure on the application server. The heavy load is now taken care of by the service. So Ken, I mentioned that Azure can handle the scaling out. What kind of scalability are we talking about here?
Yeah, we're talking about up to 1 million concurrent connections and more.
Wow, that's quite impressive. You know, what's more important to me is that achieving this kind of scale as a Socket.io developer, I only need to make a few lines of code change, as you demonstrated earlier. So that's it. If you are a Socket.io developer and would like to learn more about how you can leverage the new Azure capability, you can check out the link below. And if you're new to Socket.io, we recommend you having a look at its documentation. And also you can check out the step-by-step tutorial of how to build a code streaming app where one person writes code and other people on the internet can watch every keystroke in real time.
Thank you for watching. Yeah, we hope you find this session useful and go building real-time apps with Socket.io.